Hi, today we're doing 3-3, that's prove lines are parallel. The big question here is how do you prove that lines are parallel? So corresponding angles converse. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. And this is the converse of what we had before because it's like we've switched the if and then parts. So now we're saying if we've got lines cut by a transversal and we know the angles are the same, then we know the lines are parallel. Example 1, apply the corresponding angles converse. So it says find the value of x, so there's what we've got to do, find the value of x that makes m parallel to n. So if these two are the same, then we know m is parallel to n. So we just write an equation setting them equal to each other. 2x plus 3 equals 71. To solve this, we're going to subtract 3 from both sides, and I get 2x equals 68. Then we'll divide both sides by 2, and x equals 34. Now you could check this to make sure it's right. So 2 times 34 plus 3, that's 68 plus 3, which is indeed 71. So our two angles are the same measure, which is what we want. Pause it and try this one on your own. Okay, welcome back. You should have said 5x minus 7 equals 98. Add 7 to both sides. So 5x equals 105. If you divide both sides by 5, then x equals 21. And the question had just said find the value of x. We did that right here. So we should just check it to make sure it's right. 5 times 21 minus 7. Well, that's 105 minus 7, which is indeed 98. So these angles come out the same. We know the lines are parallel. The alternate interior angles converse. Again, we're just flipping the if and then statements. So if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if we know that these two are congruent, then we know that these lines are parallel. The alternate exterior angles converse, pretty much the same thing. If two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are parallel. So if we know that these two alternate exterior lines or angles are congruent, then we know that we've got parallel lines here. The consecutive interior angles converse says if two lines are cut by a transversal, so consecutive interior angles are supplementary. Again, remember our consecutive interior angles here and here, they add up to 180. So if those two are supplementary, then the lines are parallel. So if we know angle 3 and angle 5 add up to be 180, then we know these two lines are parallel to each other. Example 2, solve a real world problem. How can you tell whether the sides of the flags of Nepal are parallel? Well, we can look right here. Okay, we've got two congruent angles. This right here would be our transversal. So if we think about it, these are alternate interior angles. So a good answer for this one would be because the alternate interior angles are congruent, you know the sides of the flag are parallel. Again, these are alternate interior angles, they're congruent, so these lines are parallel. Extra example 2. Can you prove that the lines A and B are parallel? Explain why or why not. And it tells us right here the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, let's look at angle 1 and angle 2. They're right here. Okay, those are consecutive interior angles. Since they're consecutive interior angles and they're supplementary, they add up to 180, then yeah, our two lines A and B, are parallel to each other. So a good answer would be yes, they are parallel because the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So the two angles, are supplementary. Thus, by the consecutive interior angles converse lines A and B are parallel. Okay, so again, a good answer here. Yes, they're parallel because the measure of angle 2 plus the measure of angle 1 is 180 degrees, so the two angles are supplementary. Thus, by the consecutive interior angle converse, lines A and B are parallel. The transitive property of parallel lines. This one's kind of common sense here. So if two lines are parallel to the same line, so this is parallel to Q, and R is parallel to Q, then they're parallel to each other. Just kind of makes sense. So if P is parallel to Q and Q is parallel to R, then P is parallel to R. Kind of common sense here. So example 5, use the transitive property of parallel lines. Each horizontal piece of the window blinds shown is called a slat. Each slat is parallel to the slat immediately below it. Explain why the top of the slat is parallel to the bottom slat. So here's a slat and a blind, and we know that these two are parallel. We also know that these two are parallel, so these two are parallel to each other. We also know that these two are parallel, so these are parallel. We also know that these two are parallel, so these are parallel. You see the pattern here? If we keep on going down, we're going to be able to say that these two are parallel, and that's because of the transitive property of parallel lines. So a good answer would be each slat is parallel to the slat below it. Thus, by the transitive property of parallel lines, S1 is parallel to S16. And that is all for lesson 3.3, a very quick lesson. So have a good night, and we'll see you in class.